Hello, Mr. Brown here, your WVL physical science teacher. Today we are in chapter 13, Forces in Fluid, and we've been assigned data analysis, planetary atmospheres. How do you do this assignment? Well, that's what we're here to talk about. All right, so you will find this assignment in your physical science textbook on page 392. You have 5 questions to complete. You can turn this in using a Google Doc, a Word doc, paper pencil, or whatever format you like best. It's all good. All right, so where are we today? What's going on? Planetary atmospheres. Today we are in space. The first 4 planets in our solar system, Mercury, Venus, Earth, and Mars, and we're examining their atmospheric pressures. All right, let's get into this right away. Question number 1, which planet listed has the greatest atmospheric pressure? All right, so we look over to our table. I found atmospheric pressure, KPA. What is KPA? Oh, that's right. Okay, the PA stands for pascals. Pascals is the SI unit of pressure, right? Force over area gives you your answer in pascals. But it had a K in front of it, right? KPA. What does that K stand for? Oh, that's right. K is the metric prefix meaning kilo or 1,000. So 1 kilopascal is 1,000 pascals. All right, so now we understand what the units are in, and it's simply a matter of which one has the greatest atmospheric pressure. We can see Mercury 10 to the negative 12th power. That is really a small number. That's a low atmospheric pressure. Mercury, I don't even think you have much of any atmosphere, so we can cross that one off the list. So of the other remaining 3, Earth is at 101.3 kilopascals, Venus is at 9120 kilopascals, and Mars is at a weak 0.71. Which one do you think is the greatest atmospheric pressure? Or which is the biggest number? All right, let's move on to number 2. What chemical substance exists in all but one of the atmospheres? All right, so we're focusing in on the center of our table here. Let's see, is it helium? No, that only shows up on Mercury. Is it sodium? No. Is it oxygen? Well, it shows up in 2 of the planets, but that's it. What about argon? No, it only shows up on Earth and Mars, so it must be one of the other gases. See if you can figure out which one shows up in all but one of the atmospheres. Moving on to question 3. The bar is another unit of pressure, where 1 bar is equal to 101.3 kilopascals. Convert each of these into bars. Hey, this is converting units, so we're going to use a conversion factor. All right, so Mercury converts over to 10 to the negative 15 bar. Well, that's really low pressure, Mercury. Earth converts to 1 bar. Well, it looks like this unit has a whole lot to do with Earth atmosphere. Okay. Venus converts to 90 bars. And Mars converts to, well, let's see if you can figure that one out all on your own. Next, number 4, how much force is exerted on a 2 square meter area of Venus's surface? That's a tricky one. Well, we have to remember that pressure is force divided by area. But the first thing we got to do is we got to take the chart gave us our number in kilopascals. Let's convert it to pascals. All right, we know our pressure, we know our area. Now using algebra, we're going to move that denominator over to the other side of the equation. And finally, we will multiply 9.12 times 10 to the 6 power pascals multiplied by 2 square meters gives us our answer, 1.8 times 10 to the 7th newtons. Now, this one was tricky, all right? And what I like about it is this is a great preview of what you would encounter in the ACT. This is a 3-step problem. We had to convert to pascals, we had to algebraically rearrange our equation, and we had to multiply. A great ACT preview. So that's our answer right there. Okay, so last one, predicting on which planet would a helium-filled balloon have the smallest volume? I don't see volume show up anywhere on this table. How does volume and pressure relate? Do they have a relationship? Why, yes, that would be Boyle's gas law, where as pressure increases, volume decreases. Good old Boyle's law. All right, so what you're telling me is the helium balloon will have the smallest volume on the planet with the greatest pressure. Which one was that? Didn't we just solve that one back in question one? That's going to be the same planet that we got in question one. All right, so a really quick tutorial on how to accomplish today's assignment. All right, see you soon. Bye-bye for now.